Welcome back to week 2. Week 1 gave us the country, the governance, the laws, the departments that are allowed to exist. But a country with no roads is just land. Week 2 builds the roads, 6 isolated networks, a central connection point, service endpoints, shared infrastructure between departments. By the end of this week, you will understand how a global bank builds the roads that connect its departments without exposing one to another and without exposing any of them to the outside world. Let me show you the map. The hub and spoke network topology. Look at the diagram on your screen. 6 neighborhoods: production, HR, finance, DevOps, staging, QA. Each one a VPC. Or let's start with the production. Look at the diagram on your screen. 65,000 possible addresses inside that neighborhood. Think of the CIDR block exactly like a postal code. Every house in the production neighborhood shares the production postal code. Every house in the HR neighborhood shares a completely different one. Two separate address systems, no overlap, no confusion about which house belongs to which neighborhood. And by default, these neighborhoods are not connected by any road at all. Production cannot reach HR. Finance cannot reach DevOps. Development cannot touch production. By default, no road, no connection, no leakage between neighborhoods. 6 neighborhoods, each with its own postal code, each completely cut off from the others. But departments still need to work together sometimes. Finance needs to send reports to HR. DevOps needs to deploy into production. So, how do people travel between neighborhoods without every neighborhood having an open road straight into every other one? A single transit gateway, the central junction of the entire country. Every neighborhood connects to this one junction. It is the only way between neighborhoods. But the junction only opens the roads it has been explicitly told to open. Think about a junction with boom gates on every road leading out of it. By default, every boom gate is down. A road only opens if there is a permit for that specific route. You cannot drive from the finance neighborhood into the DevOps neighborhood unless that exact route has a permit. That list of permits, which roads are open between which neighborhoods, that is the route table. The transit gateway enforces strict segmentation. Production and finance never reach HR or DevOps directly, unless an explicit route table entry raises that specific boom gate. Think of the route table like the permit office for the entire country. Every road between every neighborhood is listed. No permit on the list. The boom gate stays down. No assumptions, no default access. Now, there is one more layer. A central AWS Network Firewall inspects traffic that travels between neighborhoods. This is called east-west traffic. Traffic that never leaves the country. Think of it like a border checkpoint on every open road, not just at the junction, but right at the entrance to each neighborhood. Even if the boom gate is up, even if the permit exists, there is still a checkpoint inspecting everything that crosses. Trust but verify on every road, every time. And CloudFront, the main border crossing for the outside world, that is week 4. Okay. Before we touch any code, let me show you the layout. The O2 networking folder. Now, I am not going to explain every file right now. We are going deep into each one later. The transit gateway, the VPCs, the subnet math, how we actually arrive at these numbers. All of that is coming. Right now, this is just the map. This is how the folder is organized. On the left, infrastructure files, main.tf, transitgateway.tf, and 6 VPC files, one for each neighborhood: production, HR, finance, DevOps, staging, QA. Each one with its own postal code: 10.1, 10.2, 10.3, all the way to 10.6. On the right, configuration and support files, variables.tf, terraform.tf-vars, the ABSA specific values, locals.tf, the CIDR helpers and common tags, outputs.tf, what week 3's security layer will consume, route tables.tf, route tables.tf, security groups.tf, VPC endpoints.tf, network firewall.tf, ramshares.tf. You will understand every single one of these as we go. But here is why it matters before we even write one line. Think about your bank account. When you send money, that request travels to one department. When you buy airtime, a different department. When you check your balance, another one. When you request a statement, another. And behind every single one of those, there is fraud detection. There is someone checking. Is this really you? Do you actually have this money? There has to be data. And that data has to be stored somewhere. There has to be a retention period. How long do we keep it? There has to be regulation. Who is allowed to see it? And if something goes wrong at 2 o'clock in the morning, someone needs to be able to find it, trace it, fix it. All of this is the network. The roads between departments, the postal codes for each neighborhood, the permits that decide who can travel where, the checkpoints that inspect everything that moves. That is what we are building this week. Let us start with main.tf.